So for wave function assignment 8 that you had to do, you were not allowed to use a calculator. That's because this question was actually from the Higher SQA paper 2017, and it was a paper 1. And as you know, in paper 1 you're not allowed to use a calculator, and it was question 14 from that paper. So it's got two parts to it. Your part A is the standard normal express a sum of sine and a cos in terms of a single trig expression. In this case it's k sine x minus a. And then the part B is hence, meaning that what you've just worked out in part A is going to help you sketch a graph. And the other thing about this is that in the higher you would have had an answer booklet, and in that answer booklet they had already drawn the axes out for you, so it is just a case of getting the points and plotting. So to begin with, the first bit, as we say, it's standard, it's routine. So here we've got root 3 sine x minus cos x. You should set that up with equating it to the format we're trying to get, which is k sine x minus a. You would then go into your formula list, and for the sine expansion of a minus b, you're looking at sine a cos b, and then the signs match for the sine expansion. So a minus inside the bracket means it will be a minus when you write out the two terms, so it'll be minus cos a sine b. So for us, what that means in terms of our a and b, we've got k sine x cos a, and then your minus sign k cos x sine a. Now remember, this is always about trying to match left hand side and right hand side, so we can clearly see here's our sine x term here, here's your sine x term here. What's round about your sine x is k cos a, so that's going in brackets as your multiplier of sine x, and then there's your cos x term, it comes next, and what's round about the cos x is k sine a, and then you've got your, so we're going to put that in brackets, and then your cos x. Now we want to match that up with what's on the left hand side, so you're looking at what does that mean that you would need to have inside your bracket here. So what that would tell you is that you would need a root 3 here to replace the k cos a with root 3, so that it reads as root 3 sine x. The minus signs are matching, but there's no number in front of the cos x, but that essentially means you've got really just like one of them. So that would tell you that the k sine a value would need to be replaced by 1. So what you'd be looking for here, when you equate your coefficients and produce your two little mini equations, we would be looking for you to have written down that k cos a was equal to root 3, and that k sine a would need to be equal to 1. And then from that, you're of course working out your value of k. So we're doing k squared, we're squaring and adding the two, just write that in. So squaring and adding these two equations, so square and add, that's the routine that you should do each time. So k squared will be equal to, and it's the square root of 3 squared plus 1 squared. Square root of 3 squared is of course 3, so you're dealing with 3 plus 1 there. So k squared is going to be 4, which means that k will have the value of 2. And of course we then need to work out our tan value, and the tan is worked out by the value for k sine a over k cos a, and in this particular instance that would mean that you should have 1 on the top and root 3 on the bottom. And from looking at all three equations here, the 1 and the cos, 1 and the sine, the 1 and the tan, they're all positive. So that would tell you that the angle of A that you're looking for would be in the first quadrant. This is, remember, non-calculator, so I would expect you to recognise the 1 over root 3 as one of your exact values, and in fact it comes from the 60-30 triangle. So you're looking, remember, to the tan of what angle, and that is whereabouts is opposite over adjacent. So which angle has got the 1 opposite it, and hopefully you can see that that would be 30 degrees. So here, right, tan, our A angle, A is going to be tan to the -1 of 1 over root 3, and that would give us the angle of 30. That allows us then to write out our expression, right, which was our root 3 sine x minus the cos x. We can now write that as 2 times, and remember it was sine x minus the value of a, which in this case is going to be 2 sine x minus 30, and that would be it. And just a little reminder of where you get all your marks for this. You'd have made 1 mark for writing out correctly the expansion, making sure you've got the k factor at both points of that, and of course correctly identifying your 2 equations is how you get the second mark, and your third mark is for the correct value of k, and the fourth mark for correctly writing out the expression with the correct angle of A in there. So then on to part B, which is where you're having to then sketch the graph with the same equation, so y equals root 3 sine x minus cos x. So the key thing will be to know to replace that, and that's what the hence bit means, replace with what you've just worked out. So you're going to sketch the graph of y equals 2 sine x minus 30. When you're sketching these graphs, the key points that you are marked on are in your graph. You need to identify the turning points, you need to identify points on the x-axis, and you need to have your y-intercept, and your y-coordinate for when your final point, your x, is equal to 360. That also needs to be there and needs to be labelled. So to begin with, just drawing the graph of y equals 2 sine x to identify the roots and identify the turning point. That's always a good place to start when you do this. So of course the sine graph is the one that starts from 0, right? So that's our y equals 2 sine x. So we can see you've got roots at 0, 0, root at 180, 0, and a root at 360, 0. What you then move on to after that is how you can sketch the new graph. What are these points going to move to? And if you're sketching x minus 30, then it means that you're looking for 30 to be added on to each of the x coordinates. So we're doing, so your 0 and your 180, they're getting 30 added on to them, and that creates your roots, your new roots in your new graph. Because what's going to happen is your graph is just going to shift like this, everything to the right. But of course, as the graph shifts, the turning point, your roots move, your turning points move. So the turning point, which was at 92 and 270 minus 2, they will move as well, and they'll move 30 degrees further on. So you basically add 30 onto your x coordinate and create your new turning points. And then the other points that you need to be aware of are the y-intercept. When you move your graph to the right like this, it looks like your starting point, your graph would move to here, but remember the graph is continuous, so you will need to make sure that you continue that down, and also this bit here of your graph would then be beyond the 360, so that's why we need to line up the y-intercept and also the final point. So to work out the y-intercept for this particular one, you would have no calculator to do this. You are still subbing in x equals 0. So into the equation, y equals 2 sine 0 minus 30. That would have given you y equals 2 sine negative 30. And a negative angle just means on a quadrant grid, you'd be going in the clockwise rather than normal procedure is anti-clockwise for angles. So an angle of negative 30 takes you into the fourth quadrant. And of course the sine is negative in the fourth quadrant, but it's still the same size of angle that you're using. So sine of negative 30 is negative sine 30. And from your 60-30 triangle, the sine of 30 is equal to a half. So sine of negative 30 will be negative a half. So subbing that in here, so we've got 2 times the sine of negative 30, so 2 times negative a half gives us a y coordinate of negative 1. And then putting that together, right, this here is your y-intercept, and the other point that lines up with that is the end point at the 360. It's got the same y coordinate. So putting all of that information into your graph, there's your y-intercept at 0, -1, your roots at 30 and 210, and your turning point was at 122 and 300 -2. And it's this last point here that you do need to make sure that lines up with a -1. And that would be your graph for the original equation, which was y equals square root 3 sine x minus the cos x. And we used the alternative version, or the other form of that, which is y equals 2 sine x minus 30 to sketch, but they're the same thing, same graph, and that's it. So key thing to remember when you're doing this, maybe work out the points in advance of trying to sketch the graph and build up to it.